Good morning, good afternoon everyone, and welcome to the second bonus episode of this series on how to make a Web3D infinite runner game. In this episode, we're gonna add some dev tools to our game and allow the programmers to easily monitor the app thanks to a little stats panel. Are you ready? Then let's dive in. In the first bonus episode, we added various improvements to our game, like camera shakes, fog in the distance, or bonus pop-up labels. These are little things that make the overall player experience better. But it's also important to think of the people making your game, and that's why tooling is important. In a nutshell, tooling is a specific subdomain of development that specially focuses on making interfaces and consoles or just debugs to monitor internal info on your program and give some feedback to the devs on your project. So it's about creating tools that aren't always pretty, but that's not really the point. The point is to show data in an intuitively readable manner so that the people who work on the game can analyze this data very easily and potentially find or fix bugs. The tools can take various forms, from just an in-game console to a full-fledged dynamic inspector of a 3D scene hierarchy, etc. They have to be made specifically for your team though, and adapted to your needs, so they aren't generic. And also, depending on the tool, it may or may not be exported in the final shipped game build. In our case, we're gonna create a basic stats panel that shows the current frame render time, the allocated memory and the FPS of the app, and that can be toggled by pressing the Enter key. We don't really discriminate between dev and prod builds, so we can say that it will be shipped in the final version, even if not many players will take a look at it. Okay, to create this debug panel, we will use another small JavaScript library called stats. It's available on GitHub over here. And this lib is a lightweight class that allows you to quickly spawn infographs in your DOM that give you a real-time analysis of some predefined or even custom user-computed values. In our case, we'll mostly stick with the predefined ones and focus on the FPS, MS and MB stats. As explained in the docs, FPS is the number of frames that were rendered in the last second, MS is the number of milliseconds needed to render a frame, and MB is the amount of memory allocated to our app. As usual, we can get a minified version of the lib by going on the GitHub in the build folder and then copy this min.js file to our vendors folder. Then we'll simply import it in the index.html and we're ready to go. To keep our codebase clean, let's create a new file called statsmanager.js and import it in the index.html as well. Then, inside this file, let's create a small class called statsmanager. This class will first create our 3 stats panels and add them to the DOM, and then it will store a reference to each of these panels so that it can update them later on in our animate loop. But before we actually dive into the JS, let's first create a container for this info in our HTML file. I'll just make a new div with the ID stats in my body tag. And then in my CSS, I'll just add some style to this div so that we're sure it is printed on top of the rest of our elements in the top right corner and with every div one below the other. Finally, we can now use the stats.js lib to really populate this div with debug panels. So let's go back to our stats manager and in the stats manager class, add a constructor. In here, we'll first get a reference to our stats div and store it as an instance variable. So once again, use the document.getElementById built-in method. And then I'll prepare an array to store my stat panels. So these panels are going to be JavaScript objects that I use and update in the animate function afterwards. And so to create these objects, I'm going to use the stats.js lib. So I just need to create a new stats object and call its showPanel method with the right debug panel ID. So for example, ID 0 is the FPS panel, ID 1 is the MS variable, and ID 2 gives me the allocated memory stat. Since I want those 3 panels, I can wrap my panel creation inside a basic for loop that goes from 0 to 2 included, and that calls the JS constructor and the show panel method. In every iteration, once I've created my panel, I need to show it in the DOM by appending its DOM element to my stats div, and I also need to push this new stat panel to my list of stats. Okay, so with this little loop, I now have my 3 panels properly set up. If I go to my main.js file and create a new stats manager in my onload callback, you see that now when I refresh my page, I have a bunch of debug panels on the top right. Something important to note though is that the memory debug, so the MB stat, relies on the memory property of the performance object. That is an experimental feature that is only available for Chromium-based browsers, but for example, it's not available on Firefox or Safari. So if you run the code on a Firefox browser, you won't see the third panel, you'll only get the first 2. With that said, you also see that at the moment, those panels aren't really displaying any data. So they've been added to the DOM and they are here, but they are empty frames and they stay still all throughout the game. To have them update and show the up-to-date data, we need to call their update method. So the update method needs to be called on each of the stats objects that we stored. Let's do this in a new function inside our stats manager called update. This method will just iterate through our this.stats array and call the update function on each item. Then in our main.js file, in the animate loop, just below the game instance.update line, we can add a new line that says statsmanager.update. And if we refresh this, we see that the panels are now updating and showing some actual data. As you run the game, you should see some slight fluctuations, but our game is clearly not too heavy, so this should stay at pretty good levels on most computers. Finally, let's add a shortcut to toggle our debug panel on and off. This way, we'll initially hide it, and only the ones that are interested in seeing this debug data will display the panel. In our stats manager, let's add a new Boolean flag, this.active, that will prevent us from updating the data if the panel is hidden. It's like the running flag in our game instance. If this value is false, then we'll just skip the update process altogether. This will avoid doing useless computation, and it will improve the performance of our app a little bit. Then let's also add a toggle function that switches the value of this flag and shows or hides the stats div panel accordingly. Now to wrap this up, let's do the same as in our game class and have a callback on the keydown event that calls this toggle function if we press the enter key. I'll call the toggle function once at the end of the constructor so that the panel is hidden at first. And now, whenever I press the enter key, my panel just toggles on and off and the data is updated only when I see the stats panel. So there you have it. In this episode, we saw how to add a simple debug panel thanks to the stats.js library. It can be toggled on and off using the enter key. It is not fully cross-browser compatible because it relies partially on the memory property of the performance API that is not available everywhere, but it is already a basic example of tooling and it can help you quickly catch if something is wrong with your game. Next time, the third bonus episode will focus on UI and HTML manipulation via JavaScript. So we'll see how to replace some of our HTML handwritten elements with JS dynamically generated ones, and we'll see how to make the index even more agnostic of the game than it is at the moment. I hope you enjoyed this episode, and I'll see you soon in the next one.